state and backup tokens. I think this is a very famous Leetcode problem, and although it's really difficult to understand maybe from the beginning, but after you understand the problem, it's gonna be a really good problem. Yeah, so we have backup tokens, and they're gonna be value for this tokens array, and initially we're gonna have a power, and basically we have two directions, and we have two decisions. That is face up or face down, but we cannot choose both of them. We can only choose one. So what is face up? So if your current power is at least tokens I, you may play token I, losing tokens I power and gaining one score. Yeah, so this is for facing up. And you have to understand it by the examples. Yeah, because if you directly say it, maybe you don't understand what is the meaning by that. So your current power is at least tokens I, and what is tokens I? There's no numbers. You have to use examples to understand it. Yeah, let's first try to understand face up. So according to the first example, so since your score is 0 from the beginning, yes, my score is 0, initially you cannot play token face down. Why? Because initially your power is less than tokens I. Yeah, because for all the tokens there's only 100 and 50 is less than 100. So it means you can not play face up and you cannot play face down. Because if you were to play face down, you're gonna at least have one score. But initially your score is 0. Definitely you cannot play face down and you cannot play face up because your power is at least tokens I. And yeah, so your power is 50. 50 is not at least 100. So for the first example, you're gonna return a 0. And now let's check the second example. So because my power is 150 and I have tokens 100 and 200, but this 150 is more than this 100. So this means I can play the token face up. So for the face up, I reduce my power, so the power gonna be 50. 150 minus 100, so it's gonna be 50. And my score gonna be increased to 1. So this is gonna be the first step. And now, do I need to play face down? Because maybe I want to play a face down, maybe not. So there's no need to play face down, because if I play face down, my score gonna reduce from 1 to 0. Yeah. But it is still okay. But sometimes we need to play a face down, because after playing this face down, we're gonna collect more scores and we can play more face ups. So this is the greedy idea. So the greedy idea is that first of all, we want to do a face up, and then we're gonna decide if we can do face up, we're gonna continue to do the face up. But if we cannot do the face up, we're gonna do a face down. But there's a meaning of face down. If we do the face down, we're gonna collect more scores. Yeah, so this means our scores gonna be increased if we play a face down. After playing one face down, maybe we can place another 2 face ups. So in total, there are gonna be 4 face ups, 1 face down. So our score gonna be 3. So sometimes we need to play face down. Yeah, if we can. Yeah, so this is exactly the greedy idea. Now let's just check the third example. So we have 100, 200, 3 and 400, and our power is 200. So let's just check this example. I think after understanding the example 3, you might think of an idea to solve the problem. So initially you have 200, and we're gonna play a face up, why not? And we're gonna consume 100 power. So our power gonna become 200 minus 100. So our power gonna be 100, and we play a face up. Yeah. Now, because our power is 100, can we play another face up? We cannot, because after consumed that 100, we have to play a 200 maybe, but 100 is less than 200, we cannot play it. So why not we collect more scores by playing another playing a face down? Because by playing face down, we can collect more scores. And what scores we're gonna collect? We're gonna collect the maximum score. So at here, we're gonna play a face down. After playing face down, so our score gonna be 100 plus 400, and it's gonna be 500. And our score gonna become 0, because 1 minus 1 is gonna be 0. But after playing this face down, we can play 2 face ups. This 200 and another 300. After playing 200 and 300, 2 face ups, so we're gonna collect 2 score. So finally, we're gonna return a 2 instead of a 1. Yeah, so this is why. Now, let's just come to the conclusion of the greedy idea. So since we want to play face up first, so we want to consume the power as small as possible for the face up. But while playing the face down, we want to get the power as big as possible. So this means we're gonna sort the tokens array. Yeah, and this array is tokened by itself, but we need to sort it. So it's gonna be 100, 200, 300, and 400 because we want to sort the array first. After sorting the array, basically we can use a two-pointer idea. So from here we have a left pointer L, and from here we have a R pointer. It means from the right side. Now we just need to use the two-pointer idea to check one by one, because currently we have a power of 200. Yeah, because this 200 is more than 100, more than and equal to 100, so it means we can play this one and collect a score, and then the L pointer gonna be here. Now the score is 200, but our power is 100. We cannot play it, so it means we're gonna collect a score of 400. After collecting the score, the R pointer gonna be here. Currently, our score gonna be 500, and our score gonna be 0. Yeah, but this is the L pointer. L is less than or equal to R, and this 200 is less than 500. It means we can collect a score. So our power gonna be 300, and the score gonna be 1. And then the L pointer is still less than or equal to R. It go to the 300. 300 is less than or equal to 300, so we can collect another score. So after collecting another score, the L pointer will be here. So it means the L will be more than R. So it will go out of the while loop. So our final result is going to be 1 plus 1. It's going to be 2. So this is just the two-pointer, and with greedy and with sorting. So this is why this is a greedy problem. Because first of all, we need to sort the tokens array. After that, we're going to use a two-pointer to solve the problem. Now let's just sort the tokens and prepare a variable n. It's going to be the length of the tokens. Let's prepare a two-pointer template, LR. It's going to be 0 and n minus 1, and we're going to check while L less than or equal to R. Yeah. So first of all, we need to return a score. Let me just prepare a score and the result. So the result is going to be my final result, and from the beginning the score is going to be 0 and the result is going to be 0. So I want to check the power. So if my power is more than and equal to the tokens L, yeah, it means I can play a face up. So if I want to play a face up, first of all, I want to increase my score by 1, and I need to decrease my power by tokens L. Yeah, and let me think about it if I were to do anything else. So first, my score gonna be increased and the power gonna be decreased, and of course the left pointer L gonna be plus equal to 1 because I've already finished this one. I need to move to the next. Yeah. So else we need to check two conditions, because at here maybe the score is 0 because there's no if check. The score didn't increase, but the score is still 0. This means from the beginning the power is less than the tokens L. Yeah, it is not possible. So if the score is 0, we're gonna break the while loop immediately. So else, so this means yeah, so this means basically yeah, we can write it differently. Maybe let me write it like this way. It's better. Maybe, yeah, I'm gonna use another if. So if the score is more than and equal to 1, I think this is more clear. Yeah. So if the score is more than and equal to 1, basically we're gonna play a face down. If we were to play a face down, so the score gonna be minus equal to 1, and the power would plus equal to tokens R, and the right pointer would be minus equal to 1. And finally, we just need to return. We cannot return the score. We have to return the final result, because from here the score plus 1, but finally the score would be minus 1 if it is possible. But for us, we always want to record the maximum score. So it's going to be here. We're going to prepare a result. It's going to be the maximum of the result with the score. And finally, we just need to return this result to record the maximum score. We can have if we play the games optimally like this. Now let me just run it to check. As you can see, it works. Now let me submit it. Yeah, as you can see, it works and it's pretty fast. So this is why I like this problem, because this is exactly a greedy idea, and the greedy idea is really, really like a critical thinking problem, or it is coming from intuition or something. Yeah, but basically you need to have a template, like a two-pointer template, to solve it. Yeah, but the template is not the difficult part. I think the only difficult part is the greedy. You have to think about it, why we can use greedy to solve the problem, and the difficult part may be coming from the sorting. After you sorting the array, basically you can solve the problem. And the time complexity is n log n. So this n is the length of the token. So it is 1000 times log 1000. That is why it's so fast. Thank you for watching. See you next time.